Hey everyone, welcome to my channel. I'm Shamik and today I have got something really exciting for you. In this video, we are going to learn how to make the iconic portal from Doctor Strange using Niagara VFX system in Unreal Engine 5. So let's get started. Here I have created a base GPU emitter which is just an empty emitter template, and I'm going to use this to easily create all my GPU based particles. So first is this, obviously the sim target is GPU sim. So I have chosen this range between -1000 to 1000 because I have found that this is a good enough range so that the particles do not curl when you are going too close to it. And in the initialize particle section, I am basically syncing the lifetime with the emitter's loop duration. That is just because somehow I want the particle's lifespan to be relative to the emitter's lifespan most of the time. And next we have the sprite renderer, in which I have set a custom material, but that is not necessary. You can create this particle even with the default material. This particle color node is going to define the color of your particle, and you basically set that from your emitter itself. And you also set the alpha similarly, but this is also being multiplied with this radial gradient exponential node, and this is creating a circular mask. So now let's create our system derived from this emitter. So I will choose the Niagara system from the context menu, and here I will choose new system from selected emitter. I will choose the base GPU emitter. This is the one I just showed. I will add this and hit finish. Let's name this as Strange Portal. Alright, so I'm going to open this. The first thing I'm going to do is add a spawn rate in the emitter update section to spawn our particles. Let's set a value of 5000. So you can see the particles are spawned, but they're all spawning at the center, and that is because they don't have a shape location defined. So in the particle spawn, let's add a shape location module. Now you can see the particles are aligned in a spherical shape. I want a ring shape, so I will be adding this one. So this defines the portal's shape, but currently it is facing upward and I want it to face forward. So I will change the rotation mode to axis angle, and the rotation axis is 100 currently. That is fine, but I want to create a variable out of it by going to the make and selecting the read from new user parameter. So this automatically gets renamed to rotation axis, and its also default value is set to 100. Now what I want to add a vortex force because I want to have some movement of these particles. Currently it is static. So let's add a vortex force over here. So first I want to apply it after the shape location, and here I will just select fix this issue. So the vortex force is applied, but this is not the direction I want, and that is where I am going to use this variable to set the direction of the vortex force. In the vortex axis, I'm going to add this variable, rotation axis. So now the direction is aligned. Now I want to add some color to the particle. So in the color property, let's add a color from curve. I want a gradient curve. At the center, I want some bright yellow color like this, and I want it to slowly fade to red like this, then even darker red. Let's go with this color. And also scale, I want to increase this value for even brighter particles. You can see this will affect this a lot. All right. Yeah. Next thing I want to do is change the shape of the particles because the particles are spherical in nature, and if you notice the Doctor Strange portal, they are very spiky. So let's make these particles spiky instead. So to do that, I will change the sprite size from vector 2D from float to a non-uniform vector. So to do that, I will add multiply vector 2D by float. So this allows me to set non-uniform vector. What I'm going to do is I'm going to set the x value of the vector 2D to very low, like 0.1 or something. So the y is now 10 times the x and particles are barely visible. So I will increase this scale like something like 5. So now you can see the particle. They are no longer a circle. They are like spikes. But the issue is they are in random orientation and I want them to align with the velocity. So what I will do, I will go to sprite renderer and in the alignment, I will choose velocity aligned. Yes, now you can see the particles are aligned to the velocity. All right. So I will go to sprite size and I will add a random value here instead between 2 and 4. So now the particles size are being scaled between this range, making this a bit more random and dynamic. But I also want to make the other properties dynamic. Otherwise, this is looking like a uniform circle, something that we do not want. First, we are going to control this spread. The spread is too much. So to control this, I am going to implement a drag force over here. So this drag force is going to drag the particles back towards the origin. And to maintain the consistent force, you have to apply another force over here. I will add a vortex force. I will just add it before drag. So here also I'm getting the direction issue, which I will fix by changing the vortex axis to this variable that I have declared earlier, rotation axis. So now you can see movement in the outer particles also, but the movement is consistent. I want some dynamic movement. So I will just add in the vortex force amount. I will add a random range and I will set the value between 200 to let's say 450. I will do the same over here. We'll add a random. Let's set a different value. Let's set 250 to 500. It is now getting a initial force, but again the dispersion is too much. So I can increase the drag by let's say between 3 and 5, and it is controlling some of it. But I also want to make use of this parameter origin pull amount. This is going to add a counter force to the original vortex force, and that force is going to pull the particles towards the origin. Let's see how this works. So I will add a random value here, and I need to keep this slightly lower than this because I don't want this to overpower the original force. I just want this to control the original force. I will just add a range to 150 to let's say 300, and I will copy this. I will also do the same over here, 150 to 300. So I am going to add a wind force. You can see the wind direction already being applied. The wind speed is set to 100 and I want a bit of wind in all the directions, not only just in one direction. So I will randomize this wind speed. So let's say -1. If I set this to 100, but this is like the wind is applying to the particle throughout and I want the wind to gradually get applied. So for that I will just add a float from curve. Even here I'm going to add a random, let's say 100 to 150. The wind is gradually being applied, but in both the direction I don't want something like this. So I will just reduce the values. So I will change the curve. So let me add another force, curl noise force. I will just show you how it works. I will set this value to, let's say, 1000, and you can already see some awesome dynamic movement of the particles in a very curly fashion. So you can control the amount of curl in noise frequency. Set the noise frequency to, let's say, something like 25. But the curl force is too much. I will again randomize this value. If I want to have a relative value for all the forces so that I can uh, change the value to overall set a strength of the force. So I will just in the user parameters I will add a float, name this initial force. Let me set a value of 400. So what I will do, I will just multiply this. In A I will keep this initial force and this will be randomized. Let me randomize this between, let's say, 0.5 and 1. So I will just copy this and I will do the same thing over here also. Paste 0.5 and 1. Now I will increase the vortex initial force a bit. So loop duration is currently set at 2. So I don't want that. I want the loop duration to be very less. Let's say something like 0.2 to 0.4. Now you see the particles are very quickly disappearing. But here I want to play along with the lifespan of the individual particles. Like currently it is synced with duration. So I will add a random value here and I will just add very slighter life. So this is also way too much. So I will add between 2 to 0.4. Yeah, I think this is perfect. Alright, so the particles that we are spawning, they don't have any depth because the vortex force is also having only single axis. So we also need to have some of the particles dispersing towards other axis to make it look more realistic. To do that, I will just add some randomizations in the vortex axis. So you have the rotation axis, which will be fine. So I will just do an add vector. So in rotation axis, I will random. So initially I will set this to 0, 0, 0, 0.1, minus 0.2, minus 0.1, 0.1, 0.2, 0.1, something like this. So you can see some of the particles are also now falling in the outer side. So if we just increase the value at one angle, let's say at y, let's see what happens. You can see a lot of particles are flowing in the other directions also. So I will do the same thing over here as well. Yeah, this looks much better. Now I want to have some dynamic movement of this shape also. If you look into the portal kind of moves around a little bit, a little. There is little jittery movement of the shape, so we are going to implement that. So for that, we can go to shape location module, and over here in the offset mode, I will choose default. I'm going to lerp two vectors, and so I will just do a convert position to vector, and here I will add simulation position. This looks fine. And in the second lerp, I need to have some sort of control over how the particle is moving. All right, I will need do this, set new or existing parameter directly. So vector, I will name this as shape offset. So this one I will randomize. So, and in the shape location, I will add this value in the B, and then in alpha, I need to set the value so that it is having the to and fro movement. So I will need to have this one, a float from curve. Will do this, which means the emitter's age is going to be setting and resetting between 0 and 1 normalized. So, and this is going to be looping. So I think we are done. If I will just show you how if this works. If I set a value of 2, 1, at 1, this value is actually very low. So I will just set this value to something like -10. Yeah. Now I'm getting the dynamic movement. So what I will do, I will just add a multiply vector by float. So and here I will randomize my here 100. Yeah, you can see the movement of the ring. So if I increase this, the movement will be even higher. This is too much. I don't want this one. So I think 100 to 150 is going to be fine. So the curl noise, I don't want the curl noise throughout. I will need to add a curve over here. So let me go and add a curve, and so let me copy this, multiply, and then I will add a curve, and in the scale curve I will just paste. Let me just add this in the level and see how it looks. They are going inside the float, so because there is no collision to the particles, I will just quickly add some collision to it. This will be after this. So GPU distance fields I will choose. Yeah, you can see the particles are falling to the ground. If I add it like this, see the particles falling. But the density is very less over here, so I will just increase the density. So here, let me add some like value of 15,000. Now a lot of particles are spawning. You will notice that the particles appear quite sparse in this area. To fix this, we are going to scale them up. Let's adjust the initial scale to a uniform setting. Additionally, we will convert this into a parameter. This will allow us to adjust it directly from the details panel. I am now going to introduce a variable within the spawn rate. This addition will grant me the ability to regulate the spawning of particles more effectively. Following this, my next step is to minimize the spread. I will achieve this by decreasing the overall lifetime of the particles. I am considering having around 20 to 30% of the particles with an extended lifespan. This approach will introduce more dynamism into the particle movement. To implement this, I will add a float parameter in the particle spawn module. I will name it as execution index alpha. Now I'm going to add a float from curve, and in the curve index I will use the normalized execution index, which effectively represents the particle index normalized between 0 and 1. The way I can make use of this parameter is via lerp, where I am going to set this variable in the alpha, and in both A and B channels I am going to use a different set of random range so that some of the particles have higher duration than the others, and we can control this by adjusting this float curve. Now I find another issue where the particles are adhering to the ground as sharp spikes. To address this, we will use the lerp to smoothly transition the particle size from these non-uniform spikes to a more uniform circular shapes with the transformation based on the particle's normalized edge. For the float multiplication, I can also add a float curve with randomized scale where the particles will also gradually decrease in overall size. Now we can tweak the user-defined parameters to control the shape and size of the particles. I also want to have a couple of parameters to change the color curve and the color scale respectively. So you can see how changing this gives us some really nice color variations to our particle system. So next we are going to have another emitter which is similar to this one, but this emitter will be having a burst of ring instead of a continuous ring. So let's see how that works. First I will isolate this, and in shape location you have your distribution mode as random. I will change this to direct. Here you can see the spikes forming at the tail, but I don't want that. So in the scale sprite size module, I will adjust the alpha of the lerp accordingly. This looks really cool, and you can also see that it's colliding with the ground. So now I'm going to randomize the radius a bit. I will also add a duration range to be between zero point 0.5 and 1. I will now increase the sprite size to make our bursts look more prominent. Let's play along with the forces a bit more to get even more interesting results, starting with adding a gravity force. Now I will spend some time parameterizing this emitter so that we can easily control its behavior as well as make this in sync with the main ring emitter. Okay, so this looks perfect. Now we have the main constant ring as well as a burst of particles around it. Now I'm going to create an initial transitioning effect of the portal, starting from a few sparks to a gradual ring formation. So let's create the transition. I will make another emitter over here. I will name this as initial spark. So I will add a spawn rate and set a random range, keeping the values relatively lower because I don't want a lot of sparks. Next, I will add a velocity. Velocity mode will be in cone. For the cone axis, I will randomize a bit so that some particles can be emitted in all directions. I will also randomize the cone angle. I will add a gravity force and want to make the particles affected by the gravity gradually over time. So I will add a float curve in the z-axis and keep the gravity relatively lower to get a nicer effect. Now let's also adjust the particle duration along with the lifetime. The sparks are often spiky in nature, especially in our case, so I will adjust the sprite size accordingly. We also need to set the alignment to velocity aligned. We will randomize the sprite size to add a size variation. I need the spark to appear only at the start and then fade away. So I need to control the spawn rate with emitter's edge. For that, I will add the edge scale parameter here as well. In the spawn rate, I will add a float curve which will depend on the edge scale. So the spawn count will increase and then gradually decrease. So we won't be having particles spawning after a certain duration. I want to create another emitter that will be responsible for forming the ring from the sparks. So I will duplicate the original emitter and adjust accordingly. Instead of spawn rate, I will add the module spawn particles from other emitter. This requires a source emitter from which it can spawn the particles. So I will add our initial spark emitter as source. we can see that the particles are spawning from the other emitter. To achieve the desired effect of particles forming a ring, I will reposition the sample particles from other emitter module to precede the shape location module. This change ensures that the particles are sampled before they take on the ring formation. I will now tweak the shape location module further, adding some more controls over defining how the sampled particles converge with the original ring. Right now, our particles instantly form the ring, but I want to slow this down so we can actually see the portal forming. I will change the setting apply to particle position to output, which means we will control the position manually through the output module. I'm going to add this module set new or existing parameter. Here, I will directly set the particle position. It will be a lerp between the sample position and the ring position. In the sample particles from the other emitter module, I will also set the position sampling to output. I will use the sample position module for the A parameter and the shape position module for the B parameter in our lerp. The alpha is going to be a float curve with the index being emitter's age so that the ring can appear gradually over time. We will increase the sprite size to make the ring look more prominent. And we will also increase the spawned particles count. So as you can see, we are now getting denser ring formation. From here, it's only a matter of tweaking the parameters like the particle's lifetime and the different types of forces already applied to this emitter in order to get the expected result. I will also make the emitter's age in sync with the loop delay and the spawn length via the user-defined parameters so that as soon as the initial ring is formed, the main emitter loop can seamlessly blend with it. Alright, so that brings us to the end of today's tutorial. Here you can observe two variations of the portal effect we have created. Notice how effortlessly you can customize the effects using the user-defined parameters shown here. Additionally, I have made this available on my Patreon page. The link is in the description below. Your support on Patreon would be incredibly valuable and much appreciated. And there we have it. I hope you found this tutorial both fun and educational. If you enjoyed it, please take a moment to hit the like button and don't forget to ring the bell icon to subscribe. Your support will encourage me to create more awesome effects and tutorials like this one. For those of you interested, this effect is also available on my Patreon page. So consider supporting me by subscribing. Link is given in the description. And if you have any other ideas for Marvel effects and any other special effects that you want to see a tutorial for, drop a comment below. If you can, please include a relevant reference link so that I can better understand what you're looking for. Thanks so much for watching and I will see you in the next video.